Hello, math humans. We're going to do E2 today. We're going to be talking about the characteristics of exponential functions. Our objectives are that we're going to look at the characteristics of the exponential function, and this is what an exponential function looks like. So here is our equation. So let's break that equation down into pieces. A is going to be the initial value, or the starting value, we could call it. Okay, so how many things would I start with? It's also going to be the Y-intercept, which means that x is equal to 0. And in these cases, oftentimes x represents time. B is going to be the base, which is the rate of change. If B is greater than 1, that means that we have a growth problem. And if B is less than 1 but greater than 0, then that means that we have a decay problem. Okay? And I'm going to also just write this down. So remember that anything raised to the 0 is equal to 1. So 200 raised to the 0 is 1. And then I could have 1 over 10,000 raised to the 0, and it's still going to equal 1. So anything raised to the 0 power is 1. So for our exponential function, this is what it's going to look like. Okay, so it's going to be a graph. Okay, this is your y-intercept. So notice that's when x is equal to 0. So this is going to be A. And then B is going to determine how fast our curve grows. Okay. A couple other things to notice about our particular function. The domain is going to, and I'll write domain. Remember that domain is the set of x values. And for these, the x's can be anything. So the domain is a negative infinity to a positive infinity, are all real numbers. The range, if you'll remember, are the set of y values. And in this case, the y values are never going to go below 0. So we're going to say that this particular function has a horizontal asymptote, or however you say that lovely word, at y is equal to 0, which is this line right here, which means that this is never going to go below 0 because you can't have 0 creatures or 0 money. We hope you don't have 0 money, right? We don't want to have negative. So we're going to have a horizontal asymptote. So that means that our range is going to start at 0 and then go to positive infinity. The 0 is not included. Okay? And then in a growth situation, this is going to go up forever. Okay? And I have a couple more pieces of information about our graph. The horizontal intercept. Remember that happens when y is equal to 0 because this is our x-intercept. There are none. And then our vertical intercept, which is our y-intercept, which happens when x is equal to 0, is going to be very easy to find, right? And I'll show you how to do that on our calculator in a little bit. So that's going to be the point 0 and then y, okay? The last couple of things that I want to tell you about our graph, and so I'm just going to redraw our graph right here so we can have it for easy reference. It is an increasing function. Okay, so we would say that it increases over the domain. Remember that an increasing function means that the x values get bigger, y values are going to also get bigger. Okay, and then we can also have a decay problem. I'm just going to show you this graph. So notice that my curve would go the opposite direction. So this would be a decreasing function, meaning that as x gets bigger, y gets smaller, and we would say that this particular function is going to decrease over the domain. Okay? Alrighty. So now let's do an example. I only have a couple of quick examples to do today. Lucky us. So for example number 1, we're going to be given the equation f of x is equal to 2.7 times 1.17 raised to the x. We know it's an exponential function because x is in the exponent position. And so what I want to do is I want to fill in the data. So I want to find our initial value. Guess I don't need that extra piece right there. I want to find the base. I want to find the domain. And I want to find the range. And then the last couple of things on this one that I want to find my horizontal intercept, which is the X-intercept. And then I want to find the vertical intercept, which is your Y-intercept. And then I want to talk about, is it increasing or decreasing? And then is it growth or decay? So we have a lot of questions to answer, but they're all really pretty easy. And so I am going to put this into my calculator. So let me clear what's there. And I'm going to do 2.7 times 1.17 raised, and there's going to be my variable. And I'm going to do a zoom 6. And I'm going to sketch my graph over here from my calculator. Okay. All right, so there's my graph. And then I'm going to label the relevant information. So let's say I want to find that point right there, and I'm not exactly sure how to find it. So to find the Y-intercept, I'm going to do second calculate, and then I'm going to choose value, and I'm going to enter a 0 for x. So I'm going to do second calculate value. I'm going to say that x is 0, and notice that my cursor pops right to that point, and it tells me that it's 2.7, which is right here. Okay? All right. So we know that this is our 2.7. So our initial value, which is what happens when x is 0, is 2.7, and notice that it's right there in the equation. This is going to be b, so my base is 1.17. The domain is going to be all real numbers, or negative infinity to positive infinity. The range, remember I have a horizontal asymptote at y equals 0, so it's going to be from 0 to infinity. My x-intercept is none. The y-intercept is 0, 2.7. For this particular function, as the x values go this way, the y values are going up, so it is an increasing function. And then because this is going up, it is a growth. And we can also say that it's growth because b is greater than 1. Okay? All right, so that wasn't so bad. So now let's do one more of those with a slightly different function. So it's going to be the same basic directions. So we're going to be given this time f of x is equal to 1.5 times 0.37 raised to the x. And so I want to identify the initial value. I want to find the base. I want to find the domain. And then I want to do range. And then I want to do my x-intercept, the y-intercept, and then I'm going to talk about, is it growth or decay? I always like to put these in my calculator so I can look at it. So again, I'm going to go in and enter my equation. So I have 1.5 times 0.37 raised to the x, and I'm going to do a zoom 6. And I'm going to sketch my graph because it's nice to have it. Okay, so this one, oh, it's a little bit different, right? Notice that this is less than 1, so we have a decay problem. Okay, I don't need to find this value, but I'm going to find it on my calculator just so you remember how. So I'm going to do second calculate, value, x is 0, and notice that it tells me that it's 1.5. So this is 1.5. Okay, now I'm going to answer all of my questions. The initial value is 1.5. The base is 0.37, so this is A, this is B. The domain, again, is all real numbers, or a negative infinity to a positive infinity. This time, because my values are coming this way, I still have a horizontal asymptote at y equals 0, and it's not going to cross. So this time my range is going to be still read from the bottom up, 0 to positive infinity, even though it's a decay problem. My x-intercept is still none. My y-intercept is 0, 1.5, and this is a decay problem because as x gets bigger, y values are getting smaller. Alrighty, nice short video. I'll see you soon.